Hello, welcome to Keen's on Science and my series of slot videos, which is Shed Loads of Practice as part of your chemistry revision. The Shed Loads of Practice this time is on bond energy calculations, and we're calculating unknown bond energies. Let's dive straight in. Question 1 says calculate the bond energy of the hydrogen to iodine bond. So we're told in the question that hydrogen reacts with iodine to form hydrogen iodide. We're given the displayed formula of the reaction. We're told that energy change of the reaction is minus 3 kilojoules per mole, so it's an exothermic reaction. And then we've got a table of bond energies, and you can see we've got the hydrogen to iodine missing. So that's the value we've got to calculate. First thing we've got to calculate is the energy of the bonds broken. So we know we've got hydrogen to hydrogen bond, which is 436, and we can see we've got an iodine to iodine bond, which is an energy value of 151. So our total energy to break the bonds is 587. Our energy to make new bonds is 2 times hydrogen to iodide, which is X. We don't know these values. This is what we've got to calculate. So the total energy value we know is total energy in to break the bonds, which is 587, minus the energy needed to make new energy given out to make new bonds. So that's minus 2 lots of hydrogen to iodine. And we know overall it's minus 3 kilojoules. We can then rearrange the equation to calculate X. So 2 lots of hydrogen to iodine makes 587 plus 3, which equals 590 kilojoules of energy. So we divide that by 2 because we've got 2 lots of the bonds. So we know the hydrogen to iodine bond is 295 kilojoules per mole. Question 2 says calculate the bond energy X. We're told that in the question that hydrogen sulfide and oxygen react to produce sulfur dioxide and water. We're told that the overall energy change is 1034, and we're given the displayed formula for the reaction. So first thing we've got to do is calculate the energy of the bonds broken. So we know we've got 4 hydrogen sulfide bonds with an energy value of 364 and 3 oxygen double bond oxygen with a value of 498, giving us a total value of 2950 to break those bonds. We then calculate the amount of energy given out when new bonds are made. So we know we've got 4 lots of oxygen to hydrogen bond at 464. Alright, and we've got 4 sulfur to oxygen bonds. Now we don't know the value of those because that's X, so we're just going to say this is 4X. So we know the total energy given out when new bonds are made is 1856 plus 4 lots of X. We then calculate the energy change. So we know the energy change is the energy taken in to make to break the bonds, 2,950, minus the energy required to make given out when new bonds are made. So that's 1,856 plus 4x. We can then calculate x by rearranging the formula. So we know 4x is 3,984 minus 1,856, which gives 4x equaling 2,128. So x is 532 kilojoules per mole. Question 3 says calculate the carbon to carbon bond energy X. We're told that propane reacts with oxygen to produce carbon dioxide and water. We're given the displayed formula, and we're told in the question that the energy released when forming new bonds is 1640 moles greater than the energy needed when breaking the bonds. So that's going to be the minus energy given out as exothermic. But first we've got to do is calculate the energy of the bonds broken. So we can see we've got 8 carbon to hydrogen bonds with an energy value of 410. And we've got 2 carbon to carbon bonds, which are X, so we've got 2X. And we've got 5 oxygen to oxygen bonds with an energy value of 500, giving us a total energy value of 5,780 plus 2 lots of X to break the bonds. We can then calculate the energy value of bonds given out when bonds are made. So we can see we've got 6 lots of oxygen to carbon with an energy value of 740 and 8 lots of oxygen to hydrogen with an energy value of 460, giving us a total energy value of 8,120. We then calculate the energy change. So it's the amount of energy taken in to break the bonds, 5780 plus 2x, minus the energy given out when new bonds are made, minus 8,120. And we know the overall energy change is minus 1,640. We can then rearrange to calculate x. So we know 2x equals 700. X therefore is 350 kilojoules per mole. Question 4 says calculate the energy value of X. We're told that the ammonia reacts with oxygen to make nitrogen and water. The overall energy change is minus 1,272. We're given displayed formula for the reaction. We're told the different energy values of the bonds, and you can see we've got X with the N to N bond. So that's the bond we've got to calculate the value for. First thing we do is calculate the energy of bonds broken. So we've got 12 nitrogen to hydrogen bonds with an energy value of 391, and we've got 3 oxygen to oxygen bonds with an energy value of 498, giving a total energy intake to break the bonds of 6,186. We can then calculate the energy bonds when the bonds are energy given out when the bonds are made. So we know we've got 2 lots of nitrogen to nitrogen, which is X, so we'll say that is 2X. And we've got 12 lots of oxygen to hydrogen with energy value of 464. So that gives a total energy value of 5,568 plus 2x given out when new bonds are made. We can then calculate the energy change. So we know that's the energy taken in to break the bonds, 6,186, minus the energy given out when new bonds are made, which is 5,568 plus 2x. We know the overall change is minus 1,272. We can then rearrange that equation. So we know 2x is 7,458 minus 5,568. Therefore, we know 2x is 1,890. Therefore, x is 945. So the value of a nitrogen to nitrogen bond is 945. Question 5 says calculate the bond energy x for the carbon to bromine bond. We're told that the overall energy change for the reaction is minus 51 kilojoules per mole. We're given displayed formula in the equation, and we're told the different energy values of each bond. You can see X is the missing carbon to bromine bond, and that's the one we've got to calculate. First of all, we've got to calculate the energy of bonds broken. So we know we've got 4 carbon to hydrogen bonds at 412 energy value, and we've got 1 bromine to bromine energy value of 193. That's a total energy taken in of 1,841 to break the bonds. We can then calculate the energy needed given out when new bonds are made. So we've got 3 lots of carbon to hydrogen, energy value of 412. We've got a hydrogen to bromine, energy value of 366, and we've got 1 carbon to bromine, which is X. So we put plus X. We know that's a total of 1,602 plus X. We can then calculate the energy change. That's the energy taken in to break bonds, 1,841, minus the energy given out when new bonds are made, 1,602 plus X. We know overall the reaction is minus 51 kilojoules per mole. We can rearrange that to calculate the value X. So we know X is 1,602 minus 1,892, which gives X a value of 290. So the value of the bond carbon to bromine is 290 kilojoules per mole. So this question says calculate the bond energy X, which we can see is the carbon to double bond carbon. We're told that ethane and hydrogen chloride react to produce chloroethane. We're told this reaction releases 56 kilojoules of energy greater when new bonds are made than energy needed to take in to break existing bonds. So we know it's an exothermic reaction. We're given the displayed formula in the equation, and we're told the different bond energies apart from carbon, double bond, carbon, and that's the energy value we've got to calculate. So first of all, we've got to calculate the energy of the bonds broken, taken in to break the bonds. So we've got 4 carbon to hydrogen bonds, energy value of 413. We've got a carbon, double bond carbon, which is X, which we've got to calculate. And we've got a carbon to chlorine, which is 431, giving a total value of 2,083 plus X. We've then got to calculate the energy of bonds made, which is energy given out. So we know we've got a carbon to carbon, which is 346. we know we've got a carbon to chlorine, which is 339, and we've got 5 lots of carbon to hydrogen with an energy value of 413, giving a total energy value of 2750. We then calculate the energy change, so it's the energy taken in, 2083, plus X, minus the energy given out when bonds are formed, which is minus 2750. We then rearrange that equation, and we know X minus 667 equals minus 56. So overall, the value of X is 611. The value of a carbon to carbon double bond is therefore 611 kilojoules per mole. Hope you found these useful. Please subscribe, and I'll see you next time.